Thank you everyone. We meet again to you. How are you? You can subscribe my channel which is known as Bidyut Flow. Today we start a new lesson of JEE IIT preliminary level class 12 which is known as Atom. The problems are being solved to the best of my knowledge and belief, okay, lucid manner, and this chapter will be finished in one shot only. The minimum value of potential difference across the two ends of a X-ray tube, lambda equals to 1 angstrom unit given, is given. A tube is at 8.34 kV. This is 4 answers. Here E equals to 4.8 at in CS system electrostatic unit, বাংলা বলে তড়িৎ স্থির তাড়িতিক একক, এবং সি দেওয়া আছে 3 × 10 সেন্টিমিটার, অর্থাৎ সিজিএস সিস্টেমের এককটা দেওয়া আছে। We have to find the answer in kilovolt unit. So the answer is very simple. We know V equals to H nu. This is the standing relation which is to be applied here. Because X-ray tube, there is the X-ray tube. Suppose this is the X-ray tube. There is a potential difference to snatch a electron from electrode. We have to give the potential difference PD, and that EV, we know EV equals to, V into Q equals to W energy. So EV is also energy, H is also energy. So we can write V equals to HC by lambda E. V equals to C by lambda. So 6.6 to 5 × 10 to the power minus into 3 × 10 to the power 10, this divided by this in CS system. We get the volt in ESU unit, which is equals to this in ESU unit. So we know 1 is equal to 300 volt into 300 volt. This is in volt unit, and 1 volt equals to 1/1000 at a kilovolt. minus 8 minus 18 plus 3 minus 15. -27 +10 -17 -17 + 2 -15 -15 464 2/16 কে 16 464 3 से 12 73 4 3 से 12. So the answer C. For a 5 kV potential difference applied across an X-ray tube, 3.2 milliampere current flows through it. The number of electrons striking the target per second. It is current. What is current? Flow of electrons. You know it. Flow of electrons per second in the opposite direction is called a current. তো এখানে I equals to NE upon T because N is the number of electrons. N is the number of electrons. NE is the total charge and T is the time. Charge by time equals current, you know. So 3.2 into 10 to the power minus 3 equals to n into 1.6 into 10 to the minus 90. This divided by 1 second. T equals to per second given here. So we can get n equals to 2 into 10 to the power 16. So answer A. The ratio of wavelengths of the emitted photon for 2 to 1 transition in lithium plus 2 H plus and H is this. For answers given here. This problem, the standing equation of this problem equals to 1 by lambda equals to R Z square 1 by N1 square minus 1 by N2 square. Here R is the Rydberg constant. And Z is the atomic number and N1 and N2 from N1 from N2 to N1 from N2 to N1. When the electron jumps from lower orbital state to the upper orbital state from N1 to N2, we get this result. It will be calculated in the next problem. So 1 by lambda for lithium plus 3 equals to 1 by 2 square 1 by lambda h. So we can write 1 by lambda lithium plus 3 is to 1 by lambda He plus is to 1 by lambda H equals to 9 is to 4 is to 1. So reversing it, we get 1 by 9 is to 1 by 4 is to 1. Here, why this is 3 for lithium? Because we know the atomic number of lithium, is equal to 3. And why? What is lithium plus 2? Lithium plus 2 means at the electron level, 1 electron present, and He plus means at the electron level 1 electron present, and what is Z? Z equals to 2, and H means 1 electron present, and its atomic number is 1. So the answer B. The relation which was used at the previous problem, how this relation comes, it is going to be deduced, because earlier it was said by me, where the problems created, this will be explained in a lucid manner and in a shortest process. We know En1 equals to minus twice pi square m z square e to the 4 upon n square n1 square h square, and En2, what is En1? The energy at the n1 orbit, at the n1 principal quantum state, this minus twice pi square m z square e to the 4 upon n2 square h square, where m is the mass of the electron, z is the atomic number of the element, E is the mass, electronic charge, h is the Planck's constant. So we know from this, suppose this is nucleus, this is n equals to 1, n equals to 2, n equals to 3, in this way. So we easily can understand that when electron jumps from this orbit to this orbit, energy will liberate, because it is a nucleus, it is the closest. So this one is at a distance from n1, at a distance from n equals to 1 to n equals to 2. So the energy, the force of attraction by plus nucleus to the electron will be less than this, in this way. Why the negative sign? Negative sign is because the in between electron and nucleus there is a force of attraction. So we can say by Bohr's postulate that energy equals to En2 minus En1. This energy, this is N2, N3, N4, so in N2, the E equals to h nu. The energy of the photon which is emerging out can be written by this. So we can write as h nu equals to so this one is established. Where this one is r equals to constant because twice per m to the form ch cube total quantities are constant, so r is constant which is known as Rydberg constant. This one is r. If the longest wavelength of UV region in hydrogen spectra is 122 nanometer, the shortest wavelength in the region of infrared ray is this. We have the standing equation 1 by lambda is equals to r whole into 1 minus n square 1 by n1 square, this minus 1 by n2 square, this in it. Because here for this is for hydrogen spectra, so z equals to 1. In the previous problem we have had the relation 1 by lambda equals to r z square whole into 1 by n1 square minus 4 n2 square. Here the question arises as longest wavelength of UV region. UV region means ultraviolet region. We know for violet the wavelength equals to 4000 angstrom, which is equal to 4000 into 10 to the power minus 10 meter equals to 4000 into 10 to the power 9 into 10 to the power minus 1 meter equals to 400 nanometer, because 1 nanometer equals 10 to the power minus 9 meter. So the wavelength should be beyond this value and will be longest, for which we have to go from, this is nucleus, this is first orbit, this is second orbit, suppose this is third orbit, so from nucleus we have to go here which is for Lyman series, for nucleus, sorry, for the first orbit we have to go in this way, which is known as Lyman series. So for Lyman series we have obtained 1 by 1 square minus 1 by 2 square unit, because if we take the next orbit for Lyman series we get 1 by 3 square. 1 by 3 square will be 1 by 9, 1 by 9, 1 by 4 greater than 1 by 9. So 1 minus 1 by 4 less than 1 minus 1 by 9. 1 minus 1 by 4, so and r times this 1 minus 1 by 4 less than r times 1 minus 1 by 9. So 1 by lambda lessens. So lambda will be largest or longest. In this way, here we obtain 1 by 122 nanometer equals to r times 1 minus 1 by 4 equals to 3r by 4 1 by 122 implies r equals to 4 by 122 into 3. Now for infrared rays, shortest wavelength for infrared ray, we know red ray, wavelength for red ray equals to 8000 angstrom, which is equal to 800 nanometer. So we have obtained a roundabout or so we can obtain the value which is greater than 800 or roundabout or so which will be greater than this, and shortest means the value will be closer to 800 nanometer and greater than 800 nanometer. It is clear to you. The lecture given here is in a lucid manner and is in a prompt manner to the best of my knowledge and belief. So here we obtain for infrared 1 by lambda equals to r times, it will be obtained at phase chain, অর্থাৎ এটা হলো লাইমান, এটা হলো বামার, এটা হলো phase chain 1 by 3 square minus if we go everything phase chain. So if we go from this to this, we get a spectrum of wavelength 1 by 4 square. Suppose this. So we get this 1 by lambda equals to r times 1 by 9 minus something. What does it mean? It means this is for the further case it will be 1 by this is 1 by 16. After that this will be 1 by 25. So 1 by 16 greater than 1 by 25. So we get 1 by 9 minus 1 by 16 less than 1 by 9 minus 1 by 25 in this way. So it is less than this, so lambda dash will be greater than this. We want to get the shortest wavelength, so for which this, if this is almost of negative value, then we can get this is almost of greater value, for which lambda dash will be almost of negative, almost of shortest value. So we get here for 1 by infinity square, for because the n2 is imagined as infinity. After that we get 1 by lambda dash equals to r upon 9, from which we get lambda dash equals to 1 by lambda dash equals to 4 so 1 by lambda dash equals to r by 9, 4 by 122 into 3 into 9. So lambda dash equals to দুই 8 9 72 2 চৌতে 4 7 আমাকে 9 আর 7 16 দিস বাই 2 823 nanometer. So answer will be B. Answer will be B. The wavelength of K alpha line of X-ray emitted from an element of atomic number Z equals to 11 is lambda if the wavelength of K alpha line of X-ray emitted from another element is 4 lambda, then the atomic number of that element. Just using Moseley's law, root Z equals to K times Z minus B. For K alpha line, we know B equals to 1. So Z equals to K square Z minus root nu equals to this is Moseley's law. So this is nu. So C upon lambda equals to K square 11 minus 1 whole square. And C upon lambda dash equals to K square Z minus 1 whole square. So this is 1, this is 2, we get 1 by 2, 1 divided by 2, we get lambda dash by lambda. Four lambda given equals to so answer C. Number 7 problem, for which of the following transitions in each atom the photon of minimum wavelength will be emitted? The photon of minimum wavelength will be emitted means photon energy equals to h nu, so hc by lambda. So the minimum wavelength means this will be minimum, so this will be maximum, so h nu p max, for which transition energy of photon will be maximized. So first we draw the energy levels. These are energy levels: n equals to 1, n equals to 2, n equals to 3, and n equals to 4. For n equals to 1, minus 13.6 eV for n equals to 2 minus 3.4 eV, for n equals to 3 minus 1.51 eV, and for n equals to 4 minus 0.85 eV. How this data comes? This data comes from En equals to minus 13.6 upon n square eV. This formula. Put n equals to 1, you get this. Put n equals to 2, you get this. Put n equals to 3, you get this, and so on. Now, according to problem number A, from n equals to 2 to n equals to 1, from n equals to 2 to n equals to 1, so this is, suppose this is E1, and from n equals to 2, for B rays, for A ray, this one happens. For B rays, n equals to 3 to n equals to 1. This is, suppose this is A2. Some numbers for C rays, n equals to 4 to n equals to 2, n equals to 4 to n equals to 2. This is for, this is E3, and number for D ray, n equals to 3 to n equals to 2. This is for D. So this is E4. So we can find E1 equals to, how E1 can be found? E1 equals to this energy level minus this energy level. You will get E1 minus 13.6 minus of minus 3.4 equals to minus 13.6 plus 3.4 equals to 4 2 6 3 3 0 10.2 এত EV. E2 equals to this energy levels to be taken. So minus 13.6 minus of minus 1.51 equals to minus 13.6 plus 1.51 equals to, gives 0 here. Minus this equals to minus 1 একানব্বই দশ 6 আর 6 0 একানব্বই দশ 6 0 12.09. Now E3 gives you as from n equals to 4 to n equals to 2. So this will be minus 3.4 minus of minus 0.85. This will gives you minus 3.40 plus 0.85 equals to 5 আর 5 10, 9 আর 5 14, 1 আর 5 5 2, 9 আর 5 14, 1 আর 2. E3 and E4, what is E4 value? E4 means from 3 to 2, so minus 3.4 minus of minus 1.51 equals to minus 3.4 plus 1.51 equals to 1 আর 1 9 10, 6 আর 8 14, 2 আর 1 3 এত EV. So E2 gives you the maximum energy. E2 gives you the maximum energy. Why this minus? What is the importance of this minus value? This is the nucleus and electron. There is a force of attraction. So this is minus value. Now in mathematics we know minus 12 less than minus 11, but here this concept is not good, is not true, because here the minus sign for force of attraction, and so we have to count 12 greater than 11, this to be counted, because all are in negative values. There is no positive value, no 1 or 2 or 3 positive value, কোনো ধনাত্মক ভ্যালু নেই এখানে, সমস্ত ঋণাত্মক ভ্যালু। সুতরাং যেখানে সমস্ত ঋণাত্মক ভ্যালু সেখানে minus 11 minus 2 এর মধ্যে যে ক্লারিফিকেশন, যে পার্থক্য, সেটা ওইভাবে হবে না, ম্যাথমেটিক্স মতো হবে না। কি হবে? এটা -12 হয়ে গেল, 12 greater than 1 in this sense, that is -12 greater than -11. In this sense you have to study this matter. So we get for E2, and for which we get E2, so for which we প্রথমে আমরা দেখিয়ে দিয়েছি ইকুয়ালস এই চিহ্ন থেকে দেখতে পাচ্ছেন ল্যামডা যদি মিনিমাম হয় তাহলে আমাকে এইচ নিউটা ম্যাক্সিমাম হতে হবে। সো ফর ল্যামডা মিনিমাম উই হ্যাভ টু এনার্জি, we have to get energy of maximum value, so E2. So what is E2? E2 comes from n equals 3 to n equals to 1. This one is E2. So answer will be B. An alpha particle of initial kinetic energy 12 MeV is scattered by an unknown nucleus through an angle 180 degree. If the distance of closest approach of the alpha particle is 321 minus 15 meter, then what is the atomic number of the unknown nucleus? Here is the problem, which is based on two positively charged, the force of two positively charged particle. One is alpha particle, another one is unknown nucleus. And for answers, you can see that the four answers are larger than alpha particle, because the atomic number of alpha particle is 2. So the force of repulsion will take place from an unknown nucleus side to alpha particle. alpha particle के alpha কণাকে ওই অজ্ঞাত নিউক্লিয়াসটি বিকর্ষণ করবে। তো সেখানে we have given the EK, the energy, kinetic energy of alpha particle given, and that will be calculated by the closest distance of closest approach, which was given as R0 by the relation EK equals to Z1 Z2 E square this divided by 4 pi epsilon 0 R0. When that force in opposite direction is given from infinity to that point, R0 point, this will be the measurement of that kinetic energy, and it will be shown after solving the problem. So answer, from which you can write Z2 equals to Z1 square 4 pi epsilon 0 EK R0. We know 1 by 4 pi epsilon 0 equals to 9 into 10 to the power 9 SI system. So this will be 1 by 9 into 10 to the power 9 into EK given 12 into 10 to the power 6 EV, and that EV equals to 1.6 into 10 to the power minus 19 joule, because 1 EV equals to 1.6 into 10 to the power minus 19 coulomb into 1 volt equals to 1.6 into 10 to the power minus 19 joule. So this out R0 equals to given 3 into 10 to the power minus minus 15 নিচে হচ্ছে 0 * 2 * e square 1.6 × 10⁻⁻19 স্কোয়ার। সো উই অবটেন 9 × 18, এখানে 3 × 36, এটা কাটলো আর 2 হবে এখানটা। সো 2 × 1.6 মানে 3.2, this divided by 2.56 into 10 to the power 6 minus 19 minus तो minus 28, नीचे 10 to the power 9, এখানে minus 38 plus 9 minus 29 equals to 3.2 into 10. This divided by 2.56 is equal to 32 by 2.56 equals to calculate it again. 32 by 2.56 equals to 12.5. So the answer C. Prove that EK equals to this from previous problem. We said that the previous problem we said that the relation which was used to solve the problem will be solved, will be proved. So let us prove the relation. We know force of repulsion between alpha particle and that unknown nucleus from the previous problem. I am saying from the previous problem. So this one equals to Z1 Z2 is square this divided by 4 pi epsilon 0 into r square. This is force. If the distance between them was r, then from Coulomb's law, because Z1 first one nucleus unknown nucleus charge of unknown nucleus Z1 Z2e and charge of alpha particle is Z1e. For alpha particle it will be 2. So now the EK will be measured by work done method. How? It was said at previous problem that from infinity in the opposite direction, if the force is being calculated, then from infinity to that point, closest point, R0, we will get the গতি শক্তি, কাইনেটিক এনার্জি, গতি শক্তির পরিমাণটা আমরা পাবো। কিভাবে পাবো? বিকর্ষণ বলটার অপোজিটে যদি বল প্রয়োগ করি, সেই বলটা যদি ফ্রম ইনফিনিটি থেকে ওই R0 পয়েন্টে নিয়ে আসা হয়, তাহলে যে ওয়ার্কটা ডাউন করতে হবে, যে কার্যটা করতে হবে, সেই মাপটাই হলো সেই গতিশক্তির মাপটা। কারণ আমরা জানি কোনো বস্তু যখন এগিয়ে যায় গতিশক্তি নিয়ে, তাকে ব্রেক দিয়ে স্টপ করাতে হয়। ব্রেক মিনস অপোজিট ডিরেকশনে ফোর্সটা, the force which is acting at the opposite direction to the motion of the body, the motion of the particle. এখানেও তাই হচ্ছে। So the work done will be minus of F dr from infinity to R0 point equals to Z1 Z2 square this divided by 4 pi epsilon 0 r square dr equals to minus Z1 Z2 square upon 4 pi epsilon 0 r0 1 by r square dr equals to minus Z1 Z2 square upon 4 pi epsilon 0. এখানে इंटीग्रेशन -1/r হবে इनफिनिटी r0. We know integral 1/r square dr equals to r to the power minus n dr equals to r to the power minus to plus 1 minus to plus 1 plus c. C is arbitrary constant. You know equals to -1/r plus c. For definite integral, this will be this. So z1 z2 square upon 4 pi epsilon naught. এখানে কি আসছে মাইনাসটা আউট করে দিলাম 1/r0 minus 1/infinity. So 1/infinity 0. So we get w equals to z1 z2 square upon 4 pi epsilon naught r0. If 10,000 volt are applied across an X-ray tube, the ratio of wavelength of the incident electrons and the shortest wavelength of X-ray coming out of the X-ray tube is so answer. First we have to suppose the electron 10,000 volt applied on the X-ray tube. So electron coming out the ratio of wavelength of the incident electron 10,000 ভোল্টে যে ইলেকট্রনটা আছে ফ্লো অফ ইলেকট্রন যেটা আছে অর্থাৎ কারেন্টটা আছে বলতে ভোল্টেজ আছে তার যে ওয়েভলেন্থটা সেটা আমরা বার করব বাই মিনস অফ de Broglie wavelength lambda equals to h upon mv where we get half mv square equals to ev. So m square v square half m square v equals to mev. So mv equals to root over twice mev. So this one to be put here, lambda equals to h upon root over twice mev. Now the shortest wavelength of X-ray coming for which we get ev equals to h c by lambda. So lambda x equal to hc upon ev. So lambda of electron lambda e upon lambda x equals to h upon twice mev into ev upon hc. So we can write ev out, this ev. So ওটার মধ্যে আসছে E by M into V by 2 এখানে আসছে 1 by C. This put now নিচে 3 into 10 to the power 8 because this system is in SI system, and উপরে কথা C by M has given 1.8 into 10 to the power 11 এবং V by 2 means 10,000 by 2 5,000 5 into 10 cube. This is equal to 590 3 into 14 3 into 10 to the power 7, this divided by 3 into 10 to the power 8 equals to 1 by 10. So we can write lambda E equals to lambda X equals to 1 is to 10. So answer 1 is to 10, answer A. So this is all about your today's class. We will next meet you for the next class. Thank you for that time. My channel name is Bidyut. You may subscribe it if you like it. Thank you.